Thin layer chromatography, or TLC, is a technique that's used to separate amino acids after they've been hydrolyzed. So let's say we've taken a polypeptide, we've hydrolyzed it, and we want to know what amino acids made up that polypeptide. So it's all about working out what those amino acids are. It's very similar to paper chromatography, but the paper is replaced by a chromatography plate consisting of a thin, flexible plastic sheet coated with a thin layer of silica. The other word for silica is silicon dioxide. So it's a white powder on a plate, and we'll call that the stationary phase. And a small spot containing the mixture of amino acids is placed on a line which is about 1 centimetres from the bottom of the plate. So here's my line, and I'd put a amino acid spot just here, like that, and the whole plate here will be placed in a tank, like that, and in the tank you would have a solvent. The solvent would only go up to about 0.5 centimetre. Obviously, because we don't want the spots to go inside the solvent. And a lid is placed on the tank as well. And the reason why a lid is placed in the tank is that the inside of the tank then becomes saturated with the solvent. So the whole tank is full of the solvent vapour, and the solvent is allowed to rise up the plate. So the solvent line here would gradually rise up the plate, and as it does so, it carries the amino acid with it, and each amino acid in this mixture here would lag behind the solvent a little bit, and to the extent that it depends on the affinity of the solvent compared with its affinity for the stationary phase. So essentially how each amino acid is attracted to either the solvent or the stationary phase. The solvent itself, we call that the mobile phase. And when the solvent is reached almost the top of the plate, let's just draw another line here, the plate is removed from the tank, and the position at which the solvent front is moved is marked on this here. Now the thing is, this mixture of amino acids, let's say there's one here, it's moved from there to there, and another one is moved from here to here. The thing is, these amino acid spots are invisible. So what we need to do is we need to spray this plate with what we call a developing agent. And what a developing agent does is it changes its colour. So one developing agent, for example, is called ninhydrin, and I would learn the name of that one. Now what anhydrine does, it turns the amino acids from invisible to a purple colour. So we can see them. Or, instead of spraying the plate with a developing agent, if we don't want to spray it with anything, we can put the plate under a UV lamp. And under UV lamp, the spots are not invisible, but instead we can see the spots. And we'll see that the spots have completely separated. We can see here that this particular mixture of amino acids contains two amino acids. We have one which moves furthest up, and that one there would have a greater affinity to the mobile phase, and this one here doesn't move as much, so it would have less of affinity to the mobile phase, to the solvent. We can quantify this movement though. We can quantify it by calculating what we call the RF value. And the RF value is given by the distance moved by the spot divided by the distance moved by the solvent. So this might be measured in millimeters, and this might be measured in millimeters as well. Therefore, RF values have never got a unit because the units are going to cancel each other out here. That's one point to note. And the other point to note is that RF values are always less than 0. So they're decimals. So for example, if the distance moved by one of the spots was 80 millimeters, and the distance moved by the solvent was 120 millimeters, then we would do 80 divided by 120, which would give an RF value of 0.67. Now, what we would do then is we would compare that value with the known value of the pure amino acid running the same solvent, because RF values can vary if you vary the solvent mixture. So we compare the RF value with the known RF value of the pure amino acid in the same solvent.